Hello, this is the third part of the fault current of unsymmetrical faults. Here we are given with an electrical network. We are given with the Z buses of positive, negative and zero sequences. And the most important thing is this double line to ground fault. We have already discussed single line to ground fault and double line fault, line to line fault. This is the third part of the unsymmetrical condition, that is double line to ground fault. Part A is to draw the zero sequence circuit. B is to find positive, negative and zero sequence components of the fault current, and fault happens at bus bar 2. Third one is we have to find the IG at this point. So we will go step by step. Here this is the part 1. I draw the zero sequence. Second part is double line to ground fault. Guys, always remember these three formulas for double line to ground fault. This one is the positive sequence, and as you already know all these values, it's already given, and you already know that this is Z bus positive sequence, negative sequence and zero sequence, all these values. You just have to remember these three formulas. And as I already discussed in my previous tutorials, that if the fault is at bus bar 2, then all these values will be 2 cross 2. Second row, second column, second row, second column. That is when you have to find the values from here, positive and negative, you have to find second row and second column, 0.1135 iota and 0.0952 iota. So simply put all these values that are given with iota, remember iota, and divide, you will get this value for positive, negative and zero. This is our part B. Now the third part is to find the IG at this point, current for this point. So IG is at bus 4. So to find the I, we have to calculate V4 first. Now we already calculated the faulty currents. So this voltages at bus 4 would be post fault voltages, and the equations for the post voltage are given like this. The equations will be same for voltages for both line to ground fault, line to line fault and double line to ground fault. These equations will never change. So as usual, this is V4D post fault. So we will take this one V4D because we have to find V4D, it's not given. And V4D, we know that V4D is equal to V pre-fault plus del V4D. Pre-fault is given in the question that it is 1. And V4D, we know that V is equal to IR, and in this case V is equal to IZ. I is always taken as negative in these faulty conditions. Now here we are taking bus 4 and fault happens at bus 2. So we can take 4 cross 2, fourth row second column or second row fourth column. 4 cross 2 or 2 cross 4, it would be same, the value would be same. So simply put these values with minus sign, take care of the minus sign and take care of the iotas, otherwise the values will be changed. You will get this one minus 0.05. This is the value of del V4. Then add it in 1 and you get the final value V4 D is equal to 0.95. One more thing you have to remember, that in this post-fault formula you are taking reactance, and it's given in the question here. It's given in the question, this one. But while finding this del V4, you are taking impedance and you are calculating it with the help of the bus matrix, and this without the bus matrix. Okay, so for V4, G for generator, V for fourth bus, and I for negative value, negative sequence. Formula is this one. V4 Gi is equal to del V4 J, same formula, this one. And as we were solving in line to ground faults, line to line faults, this value is normally equal to this value. So don't confuse while solving double line to ground fault, because now I is different. See, now I is 2.76 I. So take care of this one. And by multiplying you will get this one. Similarly, V4 fourth bus generator side zero sequence would be like this one. Then you calculate all the required values of the voltages. Now put the values one by one here, 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 and the reactances are already given. You will get the required generator positive sequence current as this one, negative sequence current as this one, and zero sequence current as this one. Now here one very important point you have to consider is that in zero current sequence, when you draw the zero circuit, you have seen that it is open-ended because this is Y without ground, so both hand will be open. So when you calculate zero sequence current, it will be zero because it is not connected to bus 4 in case of zero sequence. So we will put Ig0 is equal to 0. So I hope it understands this question. This is the last part. I will revise. Double line to ground, we have these three different formulas for sequence currents. Put values of Z buses, it's given. And with 2 cross 2 matrix, I mean second row second column, because the fault happened at bus 2. If the fault happened at bus 1, we will take first row first column. If fault happens at bus 3, we will take third row third column. Similarly, fourth row fourth column. In this case, second row second column. Put the values one by one carefully with iota signs and minus signs. You will get your required values. And then if you have to find the currents at generator, you have to first find the voltages, and the formula is same. Memorize this formula for voltage, and for V4D, V4GI and V4G0 we have this formula. For V4D, only V4D is V pre-fault plus V4D. Pre-fault is extra in this formula. V4D you will solve with normal impedance and current with minus sign. I hope it helps. Thank you.